Hey guys, it's Ken. So last Saturday I sat down for an 8-hour stream to see how much of Gyromancer Plus I could make in that time frame. I didn't expect to make a full game, but I did intend to get into what I consider improvements on the original. Did I? Let's see. Going in, I actually hadn't made any art. I cut out the idea of doing a 3D dungeon and didn't care to make gem sprites, so we went with colored squares using a color rect created in the ready method of the gem scene. I made the gems rigid bodies so that I could apply gravity and bounce to them, but I actually didn't end up implementing that because I forgot to. Instead of using the rigid body gravity, I used the same contained relocation code for swapping to bring new gems into place, having them spawn above the column and move to their correct location, creating a falling effect. This could be improved by applying an acceleration tween to move speed quite easily, and the bounce could be done programmatically, or we could bring the rigid body back into play. So we started on the gem, using an enum to track gem types. We made a static generator function so that the board could select a random type and receive the gem back as a scene to store in its own board, represented as a simple 2D array. To get the swap working, I used a simple scene called swap cursor, which drew a circle around its position that covered the gems that would swap. The board controlled where the swap cursor was positioned, making it follow the mouse but stayed clamped to the acceptable area of the board and to the center of the 4 gems that would be swapped. As a full game, this circle would be replaced with a sprite showing off the swap direction, but the circle worked for testing here. An important executive decision that had to be made was which corner of the swap the gem hovered over was tracked as. Here's some image examples. I decided to go with bottom right because that let me divide the mouse position offset by the gem width and floor the result to get both the center of the 4 gems and the board access indices of the bottom right gem. Plus, it felt more natural to me. The gems track the position they're intended to end up in, and whenever they're not at that position, they move to it. So when we swap, we tell each gem which direction to move in, and it moves itself there. By telling all 4 gems to move at the same time, they move in unison and swap around the board. Then we do the same thing with our 2D array representation to keep it up to date. There's some blocking code that awaits for the gems to finish moving so that the user can't swap gems before they've settled. This is done with a signal in the gem, which we connect to the board before telling them to move, track how many we're waiting on, and when we've received that many signal emissions, we re-enable swapping and disconnect the signals. Matching is done with a simple scan. For every gem in a row or column, we track its type and count it as a match. When we reach another gem of a different type, we check if we've matched at least 3, get the indices, and mark those gems to be scored and destroyed. We do this for all rows and columns to gather all gems that count as matched. Then we group all of the matched gems by type, get connected groups, and the board reports this scoring back to the battle scene, which controls the status of the player, the enemy, and their abilities. For a match of 3, we score 9, 3 for each, and each gem after that is worth more. This grouping would later be extended to support bonus score and effects for team matches and cross matches, but I held off on that. Each ability the player has adds the score of each group towards its charge, counting double for groups of the ability's gem type. For our demo, I used the ruby type for the player abilities and the emerald for the enemy's abilities. If an ability is fully charged, a gem on the board is blessed and given an effect of either cross or square, meaning that when it's matched, it will not only deal damage to the enemy, but it will also destroy gems in either a cross, full row and column the gem is in, or a square, all gems around the matched gem. When an enemy's ability is fully charged, it curses a random gem, which has the same effect when matched but doesn't deal damage. But if not matched within a random number of turns, it will deal damage to the player and destroy gems in either cross or square and not count them towards the player's score. The UI is simple, but effectively all needed to display battle information and complete a full battle. This section of the game took about 6 hours, primarily due to me being bad at math, various issues caused entirely by my lack of forethought, and the time it took to test each new code step manually. Had I been smarter, or tried to do it again right now, I could probably get it down in 2 to 3 hours, but that's show business, baby. I wanted to get a demo of the dungeon section up too, so I made a quick tile set of 4 tiles for floor, wall, enemy pit, and this guy you can make fun of. I also made a player sprite with a little dagger. I drew a small dungeon using a tile map layer, a player using a character body with free movement, used the physics layer of the tile map to add collision with the walls, and added a scene manager to handle switching between the dungeon and the battle, with some state management in it to remove the enemy pit if the battle is won. If it's lost, the player respawns in the center of the dungeon and can fight again. I used Nathan Hode's Dialogue Manager plugin to quickly give this guy some conversation, which if I had more time would turn into an NPC base for both dungeons and the camp to enable talking to people and maybe buying power-ups. I didn't implement any power-ups because by the time the scene switching was done I had 10 minutes left, so I took a deep breath and accepted that I had done all I could. If you want the full project, there's a full GitHub link in the description where you can find it. And if you'd like to see me run another 8-hour challenge trying to finish this or making something else, like the video and let me know down in the comments. I've run a few game jams before, but I usually only do them with a team, so debugging and getting a more presentable finished product is a lot easier. And this has helped me recognize a lot where I still need to beef up my own skills, especially with the parts of Godot that I haven't hit yet. I actually really enjoyed doing this though. I got less done than I thought I would, but I understand why. More planning would have helped a lot, and I need to brush up on my grid math for the future, but with only 3 months of Godot under my belt, I felt very familiar with the process and was able to get to the core of Gyromancer complete, if lacking a lot of polish. Obviously, my previous years of game programming experience made this easier for me. What I really want to emphasize to any beginners out there is that even if it takes you 5 times as long as it took me, you could have all of this up and running within 40 hours, which is barely more than an hour a day for a month. If you could dedicate a single Saturday out of that month to working 4 to 8 hours, and with the acceleration you'd get from learning as you work on it, you could have a pretty full little game by the end of that month, which would impress people. Add a little art into it, make it your own, and you'd blow people away. And with that in mind, imagine starting today and putting a single hour every day into making something. By the end of the year, you'd not only be an experienced game developer, but you'd have a really good product in front of you. So if you're thinking about making games, just do it. Everything starts with a single step, and I believe in you. So go make some games. And if you need help, remember you can ask me here in the comments, over on X, or in my Twitch streams where I'm back to working on my own game, but don't mind pausing to help you out. And for more game dev and gaming content, remember to subscribe. Bye!